In this video, we will examine the third rigid transformation, or isometry, where no shape or size is changed. This time, we're just going to be changing orientation and location. It's called a rotation. Here, the definition: a rotation is a transformation by which a figure is turned around a fixed point to create an image. All right, from the pre-image. So here in the picture, we have this pre-image that is a blue triangle, and our image is this red triangle to the left there. This center of rotation is that fixed point. So if we think about a point being right here, you can see that they're pointed to. Now it's pointed to twice. This pre-image, this blue triangle, was rotated about that point. It's really hard to see that in a textbook, so we're going to take a look at it on GeoGebra. And it's going to be something that seems like we've looked at it before, and we kind of have. A few sections back, we looked at rotations, all right, and how a figure can rotate onto itself. We talked about the order or degree of that. Here is a little bit different in that the image is not necessarily going to be sitting right on top of the pre-image. Okay, it's not going to necessarily rotate around itself. It can rotate about any point, and let's see how the differences are there. So here on GeoGebra, I have a figure, and I already created a slider. This time I labeled it as just the letter A rather than the Greek letter alpha. You can name it anything, whatever is easy. So I'm going to use my transform tool, rotate about a point. So what we looked at before is sort of internal rotation, rotating about the middle, but we could rotate about any points on the edge. So if I were to rotate around a point, the directions would be to select the object and the center point and then the angle. So I'm going to select the object, the polygon. I'll choose A as my center point, and then instead of an angle of 45 degrees, I'm going to choose the letter A because that's my slider name. All right, now as I grab my slider, notice that it's rotating about A all the way 360 degrees around. You can see it can rotate about A. All right, now all of these have algebraic description as well. Like if I were to rotate that far, there would be an algebraic description. But the way we're going to just talk about it is to think about angle. We're going to think about an angle. And to do that, we're going to look at any point and then where it's been mapped to. So for example, if I were to do 102 degrees, notice that I have B originally and B prime. If you think about the angle that's formed by B and B prime, that's going to be a 102 degree angle. But the same would be true about any 2 points. So let me give you a further example of what I mean. If we look at the center point A, let's think about the point E. Where did it go? It went to E prime. I draw a line also from a segment from A to E prime. And notice I have these 2 segments. And the angle between those would be that 102 degrees. That would be the measure. And that would be true for any of the points that we mapped. If we map from A to D, and then we map from A to D prime, the angle between those 2 points would be 102 degrees. In other words, what we're saying here is it takes every point in this figure and it maps at 102 degrees about that center point. Let's take a look at what if you just rotate around a point that's not on the figure. A very common point we're going to be using is the origin. If you were to rotate about the origin, let's just see how that looks so you have a general idea about it. All right, I'm going to rotate this same figure about the origin point, and I'm still going to use my slider so we can see it dynamically there. All right, so here now you see that, notice this seems to be going around the middle or around the origin. So it doesn't have to be a point on the figure, it can be anything. And it still would have that preservation of angle. So if I were to stop at 180 degrees, if I can get it done, there it is. And I were to think about the line segments between any of the original points, like what if I think about where was G with F originally and where is G to F prime? You can see that forms a perfect 180 degree angle. That's the general idea. And then what would happen to the coordinates? Well, if you think about a 180 degree angle, what happened to those coordinates? They're exactly identical, just the signs have been changed from positives to negatives. And this will be the case with a 90 degree, 180 degree, or 360 degree, 270 degree rotation about the origin.